Okay, so this is the second part of graphing rationals. Okay, and here I'm going to focus on asymptotes, but we're going to graph these things. Now, I suggest you really take these two seriously, because your midterm test, which is going to count for 6 grades, half of it will be on doing this skill right here. Okay, so let's talk about how we do these things and how we're going to find horizontal asymptotes or asymptotes. So first part, define horizontal asymptotes. Okay, these guys represent the end behavior of your polynomial, or as x goes to plus and minus infinity. Okay, so let's take a look at an example here. I've got a polynomial, which is x squared over x squared minus x minus 6. Okay, now remember when we dealt with end behavior, we talked about the fact that for end behavior, which is what horizontal asymptotes are, only the highest order terms matter. And this is only for horizontal asymptotes. Okay, so let's take a look at this. So in other words, the end behavior of this guy right here, which would be x squared over x squared, is going to be the same. If I simplify that, that works out to be 1. So my horizontal asymptote is going to be at y equals 1. Or if you remember this from Algebra 2, we talked about that when the degrees of numerator and denominator were equal, then the asymptote was the ratio of the coefficients, and that's what we just found. Personally, I think it's easier when you can recognize the fact that it's just the highest order terms. That was our first rule, okay? And the second one then we talked about was what would happen if so when degree of denominator is greater, what is this going to do? Okay, so this would be something like x plus 3 over x squared plus 2x plus 5. Remember, we're only the highest order term, so it's going to behave like x over x squared, which looks like 1 over x. So as x goes to infinity, this thing goes to 0. Matter of fact, x goes to plus and minus infinity. This is the other thing. So when the degree of the denominator was greater, the horizontal asymptote was equal to 2. And the last one then we talked about was when they were equal, when the numerator was greater, So that will be something like x squared plus 2x plus 5 over x. Remember, just the higher order terms. So it behaves like x squared over x, which behaves like x. So as x goes to infinity, y goes to infinity. As x goes to negative infinity, y goes to negative infinity. So you have no horizontal asymptotes in this case. And if you want to memorize these rules just fine, I suggest you actually understand getting them from your terms. Okay, so let's go back to my original problem now. I've digressed off a little bit. So here's my original problem. T of x was x squared over x squared minus x minus 6. And we found our horizontal asymptote is y equals 1. Okay, now we need to find the vertical asymptotes. To do this, we need to factor, because we want to find vertical asymptotes. So vertical asymptotes are what make the denominator equal to 0. Okay. So first thing I need to do then is factor this. And this thing factors to x minus 3, x plus 2. So my vertical asymptotes then are going to be where x minus 3 equals 0 and x plus 2 equals 0. Or they will be at x equals 3 and x equals negative 2. And these are my two vertical asymptotes. The last thing you need to worry about then is the slant asymptote. Remember I talked last time on the slant only occurs if the degree of the numerator is one more than the denominator. All right, in this case they're equal, so we have no slant. And you need to be sure and write this down on your test. All right, so we've got all of these things now. We've got our asymptotes. So we know that our vertical are at x equals negative 2 and 3. My horizontal asymptote, y equals 1. You've got no slant. So now to graph this thing, we're going to need to find our x and y intercepts. Remember, x-intercept what makes, these are your zeros, the numerator equal to 0. So my numerator on this is x squared. So the only thing that makes that 0 is x equals 0. So that's my x-intercept. Except you have to check and make sure it doesn't make the denominator 0. And in this case, it does not. My y-intercept then is I come back and I plug into my original function, which was x squared over x squared minus x minus 6. And I plug 0 in, that means my y-intercept is 0. So in other words, this point goes through the origin. All right. So now we've got all of this information, except, well, we're almost ready. So what we need to do now then is start on our graph. Okay, so I'm going to put my vertical asymptotes, which are where x equals to -2. So there's one. And I also have one at x equals to 3. There are my two vertical asymptotes. I've got a horizontal then at y equals to 1. There's my horizontal. The important thing between here, you're allowed to cross the horizontal asymptote. This just tells you how it behaves at very big values of x as we get out over here. Okay, so we've got that. Now I need to come in, and I know I've got a point there. So the last thing we need to do then is figure out how this thing behaves around the asymptotes. And to do that, we pick a point very close, but just on the other side. So that's -2. So my first point then, and I'm going to come in and I've got x squared over x minus 3, x plus 2. So I'm going to pick a point just off to a little bit off to the right of -2, which would be -1.9. And I want to figure out how it behaves. So on this one, if I plug this in over here, and remember I don't need to know the number, just the sign, it's squared, so the numerator will be positive. Negative minus a negative will give me a negative for this term. And -1.9 plus 2 will give me a positive, which means that this thing goes to -infinity here. So I can graph it there. Okay, then I'm going to pick a point just a little bit off to the left. So let's take a look at x equals -2.1 and plug it in. Again, I take this point, I put it back in up here. So -2.1 squared is a positive. A negative minus a negative gives me a negative. And -2.1 plus 2 gives me another negative. Negative times negative is positive. So this thing goes to positive infinity up here. So now at this point I can graph this guy. He's going to look like this. Now I know this one has to come up through here. So I'm going to go ahead and at least draw it to there. So now I need to figure out my behavior around here. So I'm going to pick a point just over here. So let's pick a point where x equals 2.9, which is a little bit off. and I plug it back in. So 2.9 squared is a positive. 2.9 minus 3 is a negative. And 2.9 plus 2 is a positive. So this is, it goes to negative infinity. So I know I'm going to go back down here. So what happens is this thing comes up, and if you remember, this was x squared on the top, which makes sense, and so it's just going to bounce off and then come back down here. Okay? So now I've got this. Now I need to figure out what's going to happen on this side of the asymptote. So I'm going to pick 3.1. So 3.1 squared is going to be a positive. 3.1 minus 3 will be a positive. And adding two positives gives me a positive. So that means this goes to positive infinity out here. And it's going to come down and approach but not touch my horizontal asymptote. And that's the graph of your rational function. Okay, let's do one more example then. This is going to be a little bit different. On this one, we're going to start off with our rational is x squared minus 2x minus 8 over x. So I want to find my horizontal asymptote, so I'm going to go ahead and factor this guy out. It's going to be x minus 4, x plus 2 over x. So for my horizontal asymptote, remember I take just the top one, so I'm going to have x squared over x, which is going to look like x. So as x goes to infinity, y goes to infinity, and as x goes to negative infinity, my y is going to go to negative infinity. So I have no horizontal asymptotes. And this is the case where the order of my numerator was bigger than the order of my denominator. Okay, so my vertical asymptote is where the denominator equals 0. So I want, it's going to be at x equals 0 is my vertical. Okay, for the slant then. And this is a case where slant's going to be important to us. Because the order of my numerator was bigger than the order of my denominator. So I'm going to do synthetic division. Remember, my numerator was x minus 0, so I've got a 0 there. My coefficients are 1, negative 2, and negative 8. So I bring the 1 down, 0. So these two right here give you the equation of your slant, which is going to be y equals x minus 2. And because you do have a remainder, it is indeed a slant asymptote. So there's the equation of our slant asymptote. And now we've got a lot of information, and we can actually begin then. Well, the next thing we need to do is find our x-intercepts, which are our zeros. That's what makes the numerator 0. So I know x minus 4 x plus 2 has to equal 0, or x is going to equal to 4, and x is going to equal to negative 2. So there are my two x-intercepts. And then to find the y-intercept, I plug x equals 0. Well, this isn't going to work because I get 0 in the denominator. So I have no y-intercept. Okay. Now at this point, we're ready to at least begin to graph this thing. And then we'll come back in and talk about our behavior around the asymptotes. Let's get our coordinate grid set up. So I'm going to come back in, and then the first thing I want to do is to graph my vertical asymptotes. Which is at x equals 0, which is this guy right here. Or my y-axis is my my vertical asymptote. All right. Horizontal asymptotes, we had none. But we do have some idea of where this guy is going. Because as x goes to 0, so it's going to point up over here and down over here. Okay, so now let's get my x-intercepts, which are at negative 2 and at 4. And I've got no y-intercepts. So I know this thing is going to have to come through here, and it's going to have to come through that point. Now what I don't know for sure, although I rather suspect, is that it's not going to come back down. It's probably going to go on back up because this term is not squared, which it would be if it was bouncing. But let's just check this. So remember, this is supposed to be at 0, so let's pick a point over here, which would be negative 0.1. All right, and I'm going to plug that in. So I have x minus 4, x plus 2 over x. So the first test point then will be negative 0.1. Okay, negatives minus a negative is going to give me a negative. And negative 0.1 plus 0.2 will give me a positive. I'll plug that number in, it's a negative. Negative or negative is positive. So that tells me that I'm going to positive infinity, which is what I thought. So it's going to come through here and then head up. Okay, now we suspect the same thing here, because we know it's going to have to come down here. And this guy was not squared, but let's just check. So I'm going to pick a point 0.1 over here and put it in. So 0.1 minus 4 will be a negative. 0.1 positive and a positive will be a positive. And this will be a positive, which means that it goes to negative infinity, which is what we thought. And so now we come up and we connect these things. And this is what the graph of this thing looks like. And these are the type of problems you're going to have to do.